it happens to be also most research topic. That's why you have a lot of research and material available in forecasting. It's quite fascinating topic. No, it's almost like playing God, that you want to predict what is going to happen in the future, where the future is very uncertain, unknown, and you try to use some models and some things, and you try to predict the future, and that is why it is quite fascinating, I would say. In fact, when I just had joined, I was also thinking that I'll do my PhD in forecasting, which I did not do, of course, but I did it in different topic. But yes, you do have that fascination for a topic like this because it has so many different facets. It's a most research topic, and because of that, it is a very, very detailed. I'm going to try to make it as simple as possible, as minimum required as possible, to make you understand what is the minimum basic things which you need to understand. And you can actually use it for it's a very useful topic as well, frankly speaking. Most of the software, like if you have used Tableau, then if you have used SAS Visual Analytics or Power BI, where the forecasting, whatever happens, what they generally do is they use ARIMA models, okay, to do the forecast. So it's the most applied topic, I would say. So you can actually use this ARIMA using the case which you remember. We discussed one case on Walmart sales. So you can use this with Walmart sales case, and some of you could actually make it as a project. That would be a very good project for final submission. Okay, if you are interested. Okay, so forecasting is you have already done a bit of forecasting in the trimester 2, if I believe, in Dan, where you study different types of forecast and etc. The main part of forecasting, you would say there are two types of forecast. One is short-term forecast and a long-term forecast. Okay, in a short-term forecast, we would say that you can only predict one more term. Okay, so if you remember those moving average, then weighted moving average, exponential smoothing, all these kinds of forecasting methods which you used were short-term forecast methods, because you could actually do only one more term. Okay, so as against, there are also long-term forecasting methods where you have you can actually use the past data, create a model, and using that model you can predict for the future, and maybe you can predict for next 5 years, next 1 week, depending on, of course, what is the period you are using. But then you can actually do a long-term forecast using a particular model. So whenever you use long-term forecast, it is generally using a, you can say, regression model or causal relationship or regression model, or in short ARIMA models also. So using ARIMA also you can actually do a long-term forecast, and that's basically is the difference between a short-term forecast and long-term forecast. In a long-term forecast, you can actually predict for many periods than only single period. Now whenever it comes to forecast, you have you can say 4 different components of a forecast. That means your forecast gets affected by 4 different things, which I'm sure you have done it in the trimester 2. Okay, in the last year you must have done this, and I don't know how many of you remember it, but yes, you have done 4 components which affect your forecast, okay, or which are responsible for your forecast. One is trend, of course, and I think you must be calling it as a secular trend. Do you remember something like a secular trend? So what is the meaning of a secular trend is you may have a fluctuation in the short term, but if you see longer period, like year on year, there is a trend, and that is what is considered as a secular trend. Okay, so you generally, your forecast gets affected by the trend. Then you also have a seasonal component. Okay, if you remember, you have done seasonal and seasonality and removing seasonality index, and then of course deseasonalizing the data, all that you have done before. So what is seasonal component? So you may have a seasonality to the data. That means your forecast may depend on the season, which season the forecast is for. Okay, so you have some seasonality, and And you'll be surprised actually that most products, they do have seasonality. Okay, most products have seasonality. And what do you mean by most products? Even products like mobile phones, TVs, which are not traditionally considered as seasonal products, but most products do have seasonality. There are some seasons where you have high sales and there are some seasons you have low sales. In fact, majority of the products have very high sale during the festival season, especially from November to December. Okay, because Diwali and Christmas time is the maximum people buy new products. In fact, mobiles are my highest bought on the first day of Diwali, and how you manage your supply chain on that day actually depends a lot on how much profit you will make during that period. That's very challenging actually. So this is basically seasonality. So most products do have seasonality. And then if you remember, you did something like trend plus seasonal. So if you have trend and seasonality, so you had something like this. Okay, so you had a long-term trend, but within a small term there was seasonality. Then you also have other two components. So you have trend component, seasonal component, then you have cyclic component. Now if you consider cyclic component, how do I draw it? Again, something like this. Tell me what is cyclic and how it is different than seasonal. It will look very similar actually, but it is different. What is the difference? Did you discuss about cyclic component? Now all this.
Ma'am, cyclic is repetitive and seasonal need not be repetitive.
What do you mean?
The same cyclical will repeat at the same interval.
Okay, is it?
And
so seasonal also should repeat at the same interval. So my seasonality is generally either a weekly seasonal or.
Ma'am, but like in seasonality, there could be so if we see quarter-wise data, so different for different years and different quarters, the seasonality index and seasonality component may differ. But in cyclical, it is same throughout. Maybe.
Seasonal is annual, like annual.
Yes, that is the more correct answer. Seasonal is within a year. So whatever this difference you have, whatever fluctuations you have within a year, is put it as a seasonal component. And when it is beyond a year, it's basically cyclic. And cyclic is to actually do with a business cycle. Okay, so most of the businesses go through the cycle. First, you have, you create a product, then you have inception stage, inception stage where you actually slowly grow. Then you actually reach maturity. Then slowly the demand decreases, and then you add some new features. You do something, you do promotion, and again, same cycle happens. So when you say cyclic, it is actually more to do with a business cycle than any season of the you can say year. So when it is within a year, it is seasonal, and that's why actually what you said was also right, that it is not fluctuating generally. It is generally like this. Okay, so because your business cycles go through different stages. Okay, so you have inception stage, growth stage, maturity stage, and decline stage. So it will actually show that particular different stages of the product in the company. So you may not have actually studied too much about seasonal component, but all these three components, that is trend, seasonal, and cyclic, you can study from the past and you can use it for the future. Okay, so you can actually study from the past, understand, create some formulas or models, and use that for future forecast. Okay, so when you'll forecast the forecast for the future, you will actually use these three components to use the forecast. Though you may not have done this in the class, but if you see the books which you have referred, I don't know which book was referred, but the books generally have this trend plus cyclic plus seasonal. Okay, so you can actually consider all these three for the forecast in the future. The fourth component, though, is irregular component, which cannot be used in the future because it's a random. You can say white noise. We call what is white noises. It is a random component where there are no correlated errors. Okay, uncorrelated changes. and it follows a normal distribution with mean zero and constant variance. Okay, so almost similar assumptions of your multiple regression. Okay, so that is a irregular component, because do you agree that every time your forecast is not same as actual, there is always some error. Okay, so that error is supposed to be following a wide price. That means it does not have any pattern. Okay, it is completely uncorrelated, which follows a normal distribution with mean zero and constant variance. Okay, and this is how your trend is. This is what is your seasonality is, and of course this is your cyclic. You see, there's not much difference between the two, but yes, this is meant to do about a year. So you may have this seasonality is always considered within the year, the pattern. And then you have an irregular variation, which does not have any pattern, just irregular variation. Then you also discussed about the error, because if you remember what method you used for picking up a best forecast, because there is no hard and fast rule that this particular forecast works better for this particular data. You just try all of them or most of them. It's more or less trial and error method. You'll try different forecasts. The one which works best is the one which has minimum error. Okay, so if your forecast is as close as your actual, then it's a good forecast. So that's a simple rule which is followed for forecasting, and that's why you always have a measuring of the accuracy on the data. And there are few measures you have. Mean absolute error. Okay, so that MAE is there. This you may not have studied, but mean absolute percent error is another error which is much more popular in the industry than mean absolute error. Can anybody tell me why it should be? If you see the formula, what's the difference in MAPE? Okay, so most of the times actually when you do it in the industry, in fact forecasting is the most applied topic in the industry. Okay, and there are many softwares also. In fact, even SAS has SAS Forecasting Studio, which is a very elaborate and sophisticated software for forecasting. Okay, and which also has that hierarchical forecasting kind of thing where the forecast, you want a different forecast for different items, different hierarchies rather. Okay, so for example, you have a hierarchy like you are working in various countries. So then you have India as one of the country. Within India, you have different states. Within states, you have different cities. Within cities, you have different products. So I can actually have a separate forecast for each of this hierarchy. Okay, so that's basically hierarchical forecasting, which if you have to do manually, it becomes, or not manually, even using any software, it can be very tedious and complicated. But this SAS Forecasting Studio software is so easy and so good for that it can actually do it in few minutes. Okay, so that's the advantage. In fact, I had done a training program for FedEx for SAS Forecasting Studio software. It's a very fascinating software, and it can actually give you a very good forecasting power. But anyway, nevertheless, you can actually do a basic, at least a basic forecasting, and generally what you use is a MAPE. So the question is, what is the difference between the two? Why MAPE is more preferred over mean absolute error? In fact, there are two more errors. You generally don't use mean absolute error. You either use RSME, that is root mean square error, okay, or you use MAPE, okay, mean absolute percentage. So what's the difference between two? Why MAPE will be preferred over RSME? Anybody?
Ma'am, the absolute error might not be standardized, but then the percentage error is easier to view.
Okay, you are almost there. Standardized means you can see this formula where you are dividing it by the actual, and here you are not dividing by actual. So what happens is, if there are certain products which have very high demand and certain products which have low demand, so the products which have high demand may have higher error, obviously, okay, because the error will depend on the scale of your forecast, okay, or scale of your demand. So if your demands are in lakhs, obviously your errors is going to be high. But just because of that doesn't mean that that is a bad forecast. So if you divide it by the actual value, so if you divide it by lakh, then you get it in the percentage form, and then it is easier to compare across the products or across the areas. Okay, because most of the times do you agree that there will be, like, if you see the area like Mumbai may have very high demand, and the area like small places like Agra or some small places may have very low demand. So then when you are comparing on just root mean square error, you can't really compare it, because that is not divided. If your overall forecast is high, your error is also going to be high. So then you are actually nullifying the effect of the uh, value of the forecast. Okay, and that is why MAPE is the most common method used.
Ma'am, a question.
Yes.
Ma'am, for a forecasting model, what should be the ideal MAP or RMSE value to be a good forecasting model?
Uh,
Accepted, ma'am.
Frankly speaking, it is nothing like that. Okay, it is all depends. In fact, what generally a software does is it just does different models, and it will actually give you the one which has a minimum value. So there is never a good value or a bad value, but just there are other ways of understanding whether the model is good or bad. Okay, and it also depends on your business. Now it's very difficult to generalize what is good and what is bad. It also depends on what kind of product you are having. Okay, what is the investment in that product? What is the, you can say, I mean, if you can't sell it, and if you somehow have a very high expensive product, like BMW cars and all, okay, then you have a different kind of you know it depends on many things actually. Okay, it depends on that's why forecasting is a very specialized department. Okay, and not it is not what you call, it's not done by junior managers. Most of the times it is, you'll have a head person who will be doing it. And not only that, it is not also done only by the software. So even the software allows to do some not exactly manipulation, I would say, but use of the experience is also there is a way by which the software allows to change certain part in the forecast, so that whatever information, because see, when you are in the domain, you know certain things more than the software. Okay, so there is always what they call it as what it is called, there's one word for it. It's not exactly manipulation, but uh, adjustments. You can always do adjustments over the forecast on the basis of whatever information you have about the domain. Okay, so it is very, very domain specific question. How good is the forecast is a domain specific question. So you can actually Google this. So with different domain, because if you think that this kind of question is going to be asked in the interview, then it's better that you before you go for the interview for that particular company, you can, because it generally depends on that particular domain and the company. Okay, so there was, yes, I remember in FedEx they had 1%, but I don't recollect it, and that is only for the FedEx. I cannot say that the same percentage will be applied for others as well. Okay, it depends on many things. Okay, is it clear?
Yes, ma'am. Yes.
Okay, so that is about the error. So generally any forecasting model which gives you minimum error is the good model. Okay, and in fact in this particular trimester, so we are not doing training set, testing set concept, but most of the times you actually, there is something called out of sample accuracy. So that is also used in forecasting. So you actually keep a separate sample for forecasting, testing basically, and then you do the data, using the other data, you find out the make a model, and then you test it on that new data, and then see whichever model works best on the new data. That can be considered. But here it is not done randomly. In generally, the last data is considered as a out of sample data. Okay, so suppose you have, let's say, 100 weeks data, so you will consider only let's say 90 weeks data, last 10 weeks you will keep it for testing. Okay, so whatever model you will do, you will actually try that different models and see how exactly it works on those last 10 weeks and pick up the model which works best on the 10 weeks. Okay, so that's generally method is used. You don't do the random sampling for making test set and train set in forecasting. Okay, because it's a what you call sequential. No? You can't do random sampling. Okay, in fact, that reminds me, there is also one type of, have you heard about intermittent demand? Intermittent demand. There's a concept called intermittent demand. Anybody has heard about that intermittent demand?
No, ma'am.
Ma'am, is it something like at certain duration only the demand exists and then demand is not there? For example, every last week of the month, the demand will spike up and then.
Spike up, no. The demand is not continuous, it's discrete. So then you are actually
Okay.
measuring two things. You have to measure what will be the demand, and second is how often will be the demand. That will be also one of the parameter to judge. Because it's an intermittent, like for example, something like spare parts, which you don't require every time. It's a rare demand. Okay, it's not continuous demand, but you may require it in some time. So then you need to actually, there are two parameters there. You'll know that, okay, how much will be required, and second thing is after how soon it will be required. Both has to be predicted. So of course that is again considered completely different. So you have, so you don't have a continuous demand. You have some gaps in the demand, and then those gaps are not just random gaps, but they have some meaning. Okay, and then you need to actually predict the gap also. Okay, so let me just quickly go through this moving average method. Moving average is, you have done moving average, simple short-term forecast method, where you say that the forecast for the current period is the moving average, or 3-month moving average if you consider 3-month forecast of the last 3 months. Okay, you can have 4-month moving average and so on and so forth. Then you also have a weighted moving average, as you have done again. So instead of taking all months same weight, you will say that, okay, I will give more weightage to the current data and less weightage to the old data. Okay, so you can actually define weights and do the moving average. Similarly, you have done the single exponential smoothing, where you actually smooth out the data on the basis of the smoothing constant. Okay, and you can also find out the best smoothing constant and best alpha value, etc. So this is again a short-term method only. Again, there are advantages of smoothing method, advantages and disadvantages. I'm actually not discussing this because this you have already done before. Okay, this is not new. And of course, you could actually use a solver to find out the best alpha, okay, which minimizes the total error, whichever error you consider. Then you also discuss the regression model. In fact, multiple regression is the model which we discussed, where you have many independent variables. Like we discussed here, okay, if I want to say my future demand, FD, is nothing but your constant plus maybe advertising expenses, then R&D expenses, and so on and so forth. So this is basically causal model. Okay, regression model for forecasting is basically the causal model, which also we have done enough. We have done it. You have done it in the last term also, and we have done in this term also. Okay, so then we will come to this auto-regressive models. Okay, now before I go into this, there are 4 different types of models. Okay, and depending on different things, you will actually use different models on the basis of certain different concepts. So let me just take it step by step, and I will just try to explain it to you in as simple words as possible. Okay, I'm not getting into too much mathematics. This is actually a very mathematical topic. Okay, I'm not doing here theorems and proofs, not at all. Okay, I just want you to understand and relate to it. Okay, because anyway we are going to use software to do it. Okay, and then I will actually say that what is most important when you use a software. How would you really You can say make a best model. Okay, how would you make a best model, or how you identify a model and pick up a model, and what makes the model correct? Okay, so what are the requirements for having a correct model? So that is what we are going to discuss. But this is very much mathematical, I would say. I am making it as less mathematical as possible. Okay, because I don't want to get into, because once you go into the mathematics, the main purpose remains behind. I'm actually a statistician, but I myself would not want to get into too much of a mathematical part of this particular topic. Okay, especially for this topic, because it can just go too much complicated. Okay, so there are 4 different models. Okay, let me just explain. One is auto-regressive model. Then you have moving average models. Then you have auto-regressive moving average. So you have, in short, they are called as AR models is auto-regressive models. MA models are moving average models. Then auto-regressive moving average is nothing but ARMA model. Okay, ARMA, that is auto-regressive moving average model. And the last one is ARIMA models, that is auto-regressive integrated moving average model. Okay, so there are total 4 different models, and there are basically 3 different concepts. Okay, because of the permutation combinations, they are becoming 4 models, but there are basic 3 different concepts for auto-regressive models. Now let's understand what is auto-regression. Auto-regression is a regression of a variable on itself measured at different time points. Okay, so what it means is, let me just explain it to you, because when you read something, it can be very complicated to understand, but when you actually understand it in terms of example or a mathematical values, then it is very simple to understand. Okay, so what exactly is the assumption for auto-regressive model is, your past demand is an independent variable for your future demand. Okay, your past demand determines your future demand. Okay, so if I actually consider this, so if I have, say, because this is 25, so this is a period 2, so demand of period 1 is the independent variable for demand of period 2. Okay, so if you see everywhere it's the same formula, for each period you are taking the demand of the previous case. Okay, and I would call this as of 1. Okay, 1 period hold. So that is 1. Similarly, I can say 2 periods. Okay, demand of 2 periods. Tell me what it will be. So because I'm considering 2, so my current demand depends on last 2 demands. Okay, not just 1, but last 2 demands. So I can say for this one, this is blank, but this is same as this one. Okay, so your current demand depends on last 2 demands. That will be 2 periods. And what will be 3 period demands? Basically, your current demand depends on last 3 period demands. 1, 2, 3. So you can say for here. Okay. So what was the demand last 3 periods? That is what is your current demand. Yes, Aditya.
Ma'am, shouldn't be sum of previous 2 months instead of just a month? Like for the 2 period, it should be sum of the previous 2 period.
No, it is not sum. Okay, but it is cumulative. I'll come to that. In fact, good you raise this question, because in fact it will be much easier for people to understand why it is cumulative. Okay, so what it means is, if I actually consider this, and this is actually in terms of autoregressive models, this is called as lag. Okay, so when I say lag 1 is 1 period, if I consider lag 2 and lag, oh god, I thought it will work. Okay, doesn't matter. Sometimes Excel is very strange. Okay, so the lag is basically number of periods. Okay, so when I'm saying that, okay, my current demand depends on just last period demand, then it is called lag 1. When I'm saying my current demand depends on two period back demand, then it is lag 2. And my current demand depends on 3 period back demand, then it is lag 3. Now, because as you can understand, is it possible that my current demand depends on 3 period back but doesn't depend on 2 and 1 period back? Not possible. So it's basically cumulative. Okay, you will consider all three. So either I have one independent variable which is lag 1 and the dependent variable is demand, or I have two independent variables, lag 2 and lag 1, and dependent variable demand, or I'll have three independent variables, lag 3, lag 2 and lag 1, and a dependent variable demand. Okay, so I cannot consider lag 2 without considering lag 1. Why? Because it's always cumulative. Okay, remember this, because if you are using lags, remember you are using independent variables. Now tell me, you have learned regression. If I am using three independent variables, tell me how many betas I should get, how many coefficients I should get.
4.
4. Okay, beta 0, beta 1, beta 2, beta 3.
Beta 3.
Okay, and except beta 0, if I am considering lag 3, I should get all other coefficients should be significant except beta 0. Okay, that means I can say yes, lag 3 is a proper model for this case. Okay, if any one of this is not significant, I cannot use lag 3 model. So if I'm using lag 1 model, obviously you'll get two betas, beta 0, beta 1. So beta 0, as I said, is not required to be significant, but beta 1 should be significant. Then I can say yes, lag 1 is a proper model. If I'm using lag 1 and lag 2 both with this, I'll get three betas, and both this should be significant to consider the model as a correct model. Are you getting my point? So it's a cumulative, but each lag is a single lag. Okay, you cannot consider a particular lag without considering the respective lag. So in general, this is called as P lag model. Okay, so this ARIMA, AR model, that is autoregressive model, is nothing but P is the term which is used. So what do you mean by P? There are P lags for, or you can say that your demand depends on last P values, and that is why it is called last P values. Okay, so when I say P, it is P, P minus 1, P minus 2 up to P first lag, all should be considered. Yes, Nitin?
Ma'am, so if we are using lag 3 and beta 2 is not significant, then we cannot use that,
no,
right?
You cannot use. Yeah.
So even if there is one beta in the middle which is not significant, we just have to discard that model.
Yes, that
Okay.
is correct. Okay, because whenever, see, what does it mean? It has to be cumulative. You cannot say that only third period has some effect on the demand. If it has to be there, 3 periods have effect. That means you have to have all 3 lags and all 3 betas should be significant. Okay, that's a very important factor over here.
Yes, ma'am.
Okay. Okay, so is this clear? It's a very simple concept. What I'm saying is my demand or future demand depends on the past demand. Okay, and that is what is basically auto AR concept. That is auto regression is nothing but it's a variable on itself measured at different points. Okay.
So ma'am, this rule that you said of cumulation is for all 4 types of model, right?
Yes. Yes. You cannot have next unless you have the previous one. Okay. So if I'm saying any same thing is for even moving average. So even for moving average process also, you have the same concept. This is true for all autoregressive models. Okay, all should be significant. Unless if you are using a test set, then you are not using statistical method for considering a good model. Okay, and then you have enough test set and you have sure that the model works fine on the new data. Then these rules may take a backstage. But if you are using a statistical concept as decision criteria, then this is must. Okay, all should be significant. Is it clear?
Yes, ma'am.
Okay. So that is basically autoregressive model. Okay, so you can see here, this is what it is. Okay, this equation I don't want to get into how it is rewritten, etc. Then you also have a concept of ACF and PACF, that is autocorrelation and partial autocorrelation. Okay, so what is autocorrelation is? It's a correlation between Y measured at different time periods. Okay, so for example, Y T minus 1, T minus L, T minus K, and etc. etc. Different time periods when you measure the autocorrelation, the correlation, that is basically called as autocorrelation. This one autocorrelation, and then you make actually you get a function ACF and P. And partial autocorrelation is ignoring the controlling the effects of the other autocorrelations. Okay, so basically you will get two functions ACF and PACF, and they are very useful to understand what should be your model. Okay, what model will be right fit for this state. Okay, we'll come to that. Of course, these all are kind of thumb rules, and many times they don't really work. Okay, so most of the times what happens is I have taken this from a book. It's a very good book, Business Analytics, a Science of Data Driven Decision Making. It is written by Dr. Dinesh Kumar, who is, I think, yeah, he's a head of analytics in IIM Bangalore. Okay, he's quite renowned person in the analytics field, and his book is also very popular. In fact, I liked his book quite. It's a good book actually on analytics and even on statistical part of the analytics. Well, most of the times, what happens is either the statistics goes back. It's not about using statistics or not using statistics, but it is about correct statistics and incorrect statistics. Okay, unfortunately, the statistics is most of the times misused and used, incorrectly interpreted, incorrectly used. But this is a good book actually. I would recommend this book for most of the statistical concepts as a quite good book, I would say. And I say it very rarely because I myself am an author. So one author to accept a book is good, it takes really big thing to say. Okay, so is this part clear? So this is generally to understand what will be useful for what. Okay, because you need to identify values. So here in autoregressive model, the lags are termed as P. Okay, so you have a P lag. So there are certain terminologies which you follow. So for AR, it is P. Okay, then you have a moving average process. Now, what exactly is moving average process is? Unlike in autoregression, AR, what we have is, we say that your future demand depends on the past demand. In moving average process, and this is nothing to do with your moving average kind of model, it's actually a process. What you assume is your future error depends on past error. Sorry, your future demand depends on the past error. Okay, so instead of actual value, okay, instead of past demand, what is the difference between demand and error? Tell me. Demand is 25. Okay, here the past demand is 25, but what will be error? So I need a forecast also here. Okay, so suppose if I have a forecast, and suppose my forecast, suppose my forecast is, let's say 24, 27, 26, and so on. So what will be the error here?
1.
Okay, so error is nothing but difference. Okay. So equal to demand minus this. Okay, and like this you have the different errors. So what you are saying is your future demand depends on the past error. Okay, your future demand depends on the past error. So that is what is the assumption in moving average process. Okay, so is this part clear? This is for 1 lag. 2 lag is your future demand will depend on past 2 errors. Okay, 3 lag will be your future demand will depend on past 3 errors, and so on. It's the same logic. Difference here is, here I'm saying my future demand depends on past demand, and here I'm saying that my future demand depends on past error. and which seems to be logical, isn't it? Do you agree that your future demand may depend on your past error?
Yes,
Yes or
ma'am.
no? Okay, so that is exactly the moving average process means. Okay, so where the assumption here is, let me just go back here. So suppose if I say lag 1, then this is your y t plus 1. That means your actual of t plus 1 period. Instead of beta, they have used beta 0. Actually, they have used mu. So mu plus alpha 1 et. That means your error of the previous period plus et plus 1. Do you agree that this is very similar to your equation? If I say yt plus 1 is equal to beta 0 plus beta 1 x1 plus et2. Okay, only difference is there is a suffix here. Okay, so it is basically you're talking about value at each point. So yt plus 1, what was our regression equation? Y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta k xa plus error. Okay, so imagine I put t here. So yt is equal to all these betas plus error t. So if I say yt plus 1 is equal to all the betas plus error t plus 1. Okay, so what I'm trying to say is this error is always there in a regression model. Do you agree?
Yes, ma'am.
Okay, so only difference is this. So because I'm saying that my past error is one of the independent variable, so then you have a constant and you have some coefficient with et. So what will be, tell me if that is true, what will be for 2 lakh model will be yt plus 1 is equal to
Ma'am, mu
Mu
plus
plus
alpha
alpha
1
E1 plus alpha 2 E2
alpha 1
plus
et plus alpha 2 et minus 1
plus
plus
error term.
plus error term et plus 1. Okay, which is always there. Remember, this error term was always there in our regression model. Okay, is this part clear now? So what we are saying is, instead of by independent variable now is past error. Okay, so past error is one of the independent variable for the future forecast. Okay, for forecasting you are assuming past error as the independent variable, and again same concept of lag, but now it is called as Q. For AR model, the terminology is P. Okay, this lag is called as P, and for moving average process, the lag is called as Q. Okay, remember that.
So, ma'am, in the second equation, where is mu?
No, actually they have used these theorems. Actually, they have used some concepts to change this from this to this. Because remember, mu is constant.
Okay. Mu
If
is
it is,
constant. Yes.
it's because it's a stationary process with a constant mean, and you are using that concepts and actually making using different equation for using those concepts. Okay, so don't worry about that. That's what I said. I'm not making it too much mathematical because mu is constant. They've actually changed it. So then is called, so first what we did is AR model, that is autoregressive model. Then next one was moving average model. So autoregressive model assumes that your future forecast depends on past future demand depends on past demand. Okay. Moving average assumes that your future error depends, again I'm making mistake. Your future forecast depends on past error. Okay, or future demand depends on past error. Now, this is basically combination of both. That is called ARIMA model. Okay, so it's basically a hybrid model when you have both. Okay, so you have also past demand as the some of the independent variables and past error also some of the independent variables. It's a combination of both. Okay, so this is has like yt plus 1, your future forecast is a combination of autoregressive part where you have p lags for autoregressive part and q lags for moving average. Okay, so q past q errors and past p you can say demand. So your current demand depends on past P demand and past Q errors. That is what ARIMA model talks about. Okay, so ARIMA is basically P comma Q. So it's a combination of two. Now remember all, yes, any question, because I can't see chart actually when I'm
And
sharing
why
my
P
screen.
and Q are not equal? So I will say that my future demand will depend on last three, suppose last three demand and last two errors. ऐसा भी हो सकता है.
Yes, yes, yes. Any permutation. They
Okay.
are actually completely
Okay.
independent.
Okay.
Okay, that's why they are considered as different values. Okay. So for ARIMA assumptions, you have like first is like minimum 50 data points should be there. That's true. Then this is the most important variable assumption is data series is stationary. Okay, you need to have a stationary series. And what do you mean by stationary series? Okay, that is data series varies around a constant mean and constant variance. If the data is non-stationary, the data series needs differentiating or differencing, or basically addition of a time trend. If the data is trend non-stationary only, then adding a linear trend to the model will render the series stationarity. Okay, so in short, you can use all those models which we seen only if the data is stationary. Okay, there are many you can say ways of identifying whether the data is stationary. There are tests also. Okay, and what do you mean by station? Okay, let me also explain that a little bit. Okay, now I could see that. I don't know why I was not getting. Actually, there's some problem when I'm in the screenshot. I can't see the charts. I can only see some, but there's one chart, but I cannot see charts. Okay, so what do you mean by a stationary series? Suppose if you have a stationary series, what it means is if I take different at different points, I'm actually keeping a same period t. Okay, so instead of t, let me just make it 4. So I'm actually considering the values at every 4 interval. Then my this one will depend on the forecast will depend on this interval, not on t. Okay, so what is t? Suppose this I'm actually saying this is 1. Okay, 0 period. I'm starting here. This is 4th, 8th, 12th, and so on. Okay, so if I take any 4 difference here for any further or back, it should give me similar results. That is called as stationary series. If you have a trend, then you will not have a stationary series. Do you agree? Okay, so then if I actually consider the values here, because the values are slowly increasing in a factor, it will depend on what at what period I am taking the value, not only on the difference. Then it is non-stationary series. Okay, so that's the one of the indication of stationarity. So you need to have a stationary series. That means there should not be trend. If there is a trend, then you cannot say that that series is stationary. And then in that case, you need to do something to make it stationary. And the most common thing to do is differencing. Now, what exactly is differencing? Let me just tell you.
Ma'am,
Okay.
can you give any example of what is any data that would be stationary without us having to make it stationary?
Any data that is stationary actually depends. If you have a constant demand, okay, then you do have a quite stationary kind of data. So that means you don't have trend. Okay, stationary means you don't have any trend. So if you have any kind of demand which do not get affected by trend. Okay, so can you think of anything which does not have trend? So more
Now,
or less,
is it
yeah.
does not have trend, or we cannot find a specific trend?
No, it does not have trend. What do you mean by we cannot find it? There is trend, we should be able
As in, ma'am, what I'm saying is there might be so much variation that we cannot fit a trend line to it. Then that is not stationary, right?
No, it's not that. If you're saying that you cannot fit a trend, that means it doesn't have a trend. See, you don't understand. What I'm saying is, even if there is a fluctuation in the short term, if you have a long-term trend, you should be able to fit it. So you have something like this. This is still a trend. Okay. Then you will, try to remove these fluctuations and try to see the trend, that is a different case. But if you have a data like this, then this doesn't have a trend. So if you have data like this, then it is stationary. But if you have data which is having, some pattern in the, slowly increasing, then it's a trend data. It's a simple thing. Okay, so it's not whether you can identify or not. It does not have a trend. Okay, and when you say trend, it is always in the long term. So if you take year on year, is there any increase or decrease? That
Okay,
is
ma'am.
considered as a trend. Not in the short term. Always remember, we don't consider short term fluctuations. That is why it is called secular trend. Okay, so if it has a trend, you should be able to find out the trend. Okay, so let me come back here. What I was talking about is differencing. Okay, so what exactly is differencing? So if you have a trend, a differencing can help a little bit. So it can say difference 1. Okay, so what you take is a simple difference. You can just take this minus this. Okay, so that's a difference, and I can just paste it. And instead of taking this as a dependent variable, take this as a dependent variable. Okay, are you getting? So what you're doing is, you're not exactly calculating over the period of time. You're just subtracting from the previous one and just seeing whether the difference, what is the difference. Okay, we are actually nullifying that time period, the trend kind of effect. This is difference 1. Difference 2, any guess? How do I do? I can take difference of difference. Okay, so for example, here equal to this minus this. That will be considered as a difference of difference, and I can just use this. Okay, so if I can actually use this as a dependent variable, okay, that would be called as differencing. Is this clear? So differencing is done at the dependent variable level. Remember that. Okay, so when you do differencing, you do it on a dependent variable. So instead of taking this, you will take this as a dependent variable, and of course lags and P and Q, whatever you will do, and you will get the result. So in short, what you do is take a difference and try to make it as a stationary. If it is non-stationary, try to do the differencing and try to make it stationary. Then your assumptions will be true, and then only you will be able to use the ARIMA models, because that's the requirements for ARIMA models. Okay, so you need to have stationary data. Okay, if the data is not stationary, you cannot use the model. Okay, so now it is very clear. You have 3 different concepts. Okay, so you have moving average. Okay, that is P lag. Then you have ARIMA autoregressive, that is P lag. Then you have moving average, which is Q lag, and then you have difference. Okay, so differencing is basically determined as D. So you have third more component, P, D, and Q. Okay, so generally your ARIMA is basically on the basis of 3. So when I say ARIMA model, I'm not writing full. Imagine it is all full ARIMA. It is nothing but P, that is what is AR component here, then D, okay, that is what is difference component here, and I don't know why it is in middle, and Q. Okay, so what, in short, if I can identify P, D, and Q value, my problem is solved. Then I know exactly how to do the forecasting and how to do the prediction. Okay, so in short, entire ARIMA model is about identifying P, D, and Q. Okay, so that's where you are completely concentrating on. And let me just tell you that this is basically, what is this integrated moving average? When you add actually differencing in that, that is basically termed as ARIMA, that is auto-regressive integrated moving average process. Okay, so
Ma'am, for calculating in moving average, we have to know what is the forecast value, right, to come up with error. And how
but
will we come to forecast value if we do not have like a forecast value? So
you don't worry about it, because you're not doing it manually. Okay, So you
Okay.
are going to do it anyway using the software. Okay. So in short, your main logic here is you just want to identify P, D, and Q.
Okay.
Okay. So in fact, there are most software, even SPSS, SAS, then SysStat, MATLAB, everybody who has ARIMA model, they also has something called auto modeler. Okay, so they will actually try to give, like they will use all the models and try to give you a best result on the basis of the error. But unfortunately, not all are very good. Especially SPSS doesn't really work well. So though it is there is a auto modeler is there, you can't use it. So in short, you will have to use your skills to identify P, D, and Q. So that's main criteria when you are using ARIMA model.
Okay.
Okay. So it's little more complicated than that actually. I have tried to make it as, see, conceptually what I have said is completely perfectly right. Okay. So when you say moving average, you are saying that past error is responsible for future demand. Okay. But then how do you, how it is really calculated internally, that is a complicated thing which I'm actually not discussing in this class. Okay, if you want, I can actually send you some material on that. It's a very detailed topic. I can actually take this for 30 hours. Okay, it's very
Okay,
detailed.
ma'am.
It's very intense actually. ARIMA models and forecasting is a very intense topic. But as I said, it's not much needed for you people. I mean, for you, what you need is how to use it and how to really interpret using the model. That I think should be more than sufficient. In fact, each of these techniques which I have been doing it, they could be really very intense, but especially this ARIMA is very much intense. If you see, there are many places where the forecasting is taught as 30 hours, full course.
Yes, ma'am.
We also had actually, when I was area chair, I had introduced forecasting analytics as one of the topics. But no, but there was, of course, I was not teaching it, but nobody, because I had some industry person teaching it, but nobody really opted for it somehow. So it got dropped after that. So maybe management students are not much interested in forecasting. Because actually what happens is, I can understand, you will be looking for short-term period. Okay, so whatever you are doing, you need to be beneficial in the short term. And forecasting is generally a very senior person does it, not in the short term. Okay, not forecasting is very important. Okay, and it's a very crucial thing for any company. So it's not done by freshers or junior managers. It's a very senior management kind of thing. That's why it doesn't really work with this. Anyway, so this is ARIMA PDQ model building. So what you do is, okay, this is basically ACF function of a non-stationary process. So when you do ACF function, you will see this is very slowly decreasing. It is decreasing, but not slowly, not fast. Okay, so if otherwise it actually decreases very fast. So that indicates there is a non-stationarity is there, and that in that case you will have to use the difference. Okay, so that is what is the logic here. And then this is the flow chart. So first look for ACF PACF function. See whether it is stationary process. If it is yes, then obviously D is equal to 0. Now remember, though this is ARIMA P, D and Q, the same, if I put let's say D equal to 0, it becomes PQ model. That means it becomes ARIMA model. If I put P is equal to 1, D is equal to 0, Q is equal to 0, it becomes AR model. If I say P is equal to 0, D is equal to 0 and Q has some value, then it becomes MA model. Okay, so same thing, if depending on what has value and what has 0 value, you can actually consider it as different models. Okay, so plot, okay, so suppose it's a stationary, then obviously D is 0, and then you will have to find out the values of P and Q. If it is not, then try differencing 1, try differencing 2. Now as a thumb rule, and believe me, there are a lot of thumb rules in this topic, you don't generally go beyond 2 difference. Okay, so maximum 2 differencing is fine. More than that, you generally do not go. So you first try one difference, then try second difference, okay, and see whether it works fine or not. If it doesn't give you good results, then you can also try transformations, okay. So transformations can also work. You can try log transformation, root transformation, and so on. Especially it was mentioned there for homoscedasticity. Okay, if there is any heteroscedasticity, transformations really work. So these are some functions actually for different ARIMA models, which I have taken from some chapter of given by SPSS only. Okay, but believe me, this is more like a thumb rule than anything else. So this is like ACF for lag 1. Okay, this is like PACF for lag 1. Okay, this is ACF and this is PACF for lag. Okay, so this I think I will call it as LV test for lack of. I mean, I don't really want to pronounce it, and I will not be able to do justice also for this. This test, if you see what exactly this test gives you, what is important is you should know what is null and alternate hypothesis. So the null hypothesis says that the model does not show lack of fit. Okay, and alternate hypothesis shows that the model exhibits lack of fit. Now tell me if I have to use the model, should I reject or accept this null hypothesis?
Accept.
Okay, you need to accept the null hypothesis. Okay, so that is what you need to know. So if whenever you will have this test, you should accept the null hypothesis. Remember that. That's it. Just this is the summary of this. What I'll do is, because I will do only one problem, and let me just quickly do. I have still few minutes. Okay, and I'm just going to show you how exactly you handle a problem. Okay, so I'm going to do 3 problems totally. One is this, 2 more are there, but I'll be able to do only one, and that also not complete. Okay, same as what I did for the other class, because this has a lot of concepts and theory. Okay, and you will not be able to do justice unless you understand at least the basic concepts. Remember, believe me, I have done very, very less of the concepts, as much less as possible. Okay, because in reality, it could be really, really more complicated. Okay, so analyze, you have in forecasting, you have all these functions. So just whenever you want to do, first you could actually try autocorrelations, okay, ACF and PACF functions. So let me just reset it so that, so just take breakfast. Now, if you see, this is one of the hospital's data where you want to, they have given the 30 days past demand for a particular type of breakfast. If I'm not mistaken, it is idli or something. Okay, because there is another file which I'm going to use is for omelette breakfast requirement or demand for breakfast, and then you want to predict for 1 week. Okay, next 1 week you want to predict what will be the demand for that particular breakfast. So I'm just using that variable, and this is a default. I have not made any changes, and just to okay. So that will give you the ACF and PACF function. So you can see for here, you can say that, can you see it is decreasing quickly? Is it decreasing very slowly? No, it is decreasing quickly. That means there is no problem of non-stationality. Okay, this looks like a stationary series. And you can see in this PACF, one first value is beyond these two lines. Okay, so that generally indicates that P is equal to Q. Okay, sorry, P is equal to 1 could be a decent model here. Okay, so P is equal to 1 looks like to be a decent model. So anyway, that we will see. And you can also use the same to understand the stationarity. Let me just quickly, where is that? You also have the sequence charts, okay, which also give you the stationarity indication. So just put value here and just do okay. And you can see this actually gives you the stationarity. Do you agree that this doesn't show any trend or something? Do you agree? This is almost stationary here. It doesn't show any kind of trend. Okay. It has up and down and etc. So it's not exactly showing. Of course, the values are too less to understand, but yes, whatever given the values, it doesn't exhibit any indication of any trend. Okay, so it seems to be a stationary series. So once this is understood, I can just go to analyze, forecasting, create traditional models. Let me reset this because that's not fair. Then you can say what is dependent variable. And remember we had done one case called Walmart sales, no, where you had different independent variables and weekly sales was there. So you can actually use the other independent variables here. Okay, so it's not that only the you can say trend is or time series is the only factor which may affect demand. You may have other factors as well. You can also define events which are, like suppose you have defined any promotional events and all, you can define that also, which can actually capture that information and can give you better forecast. Now, expert modeler, as I said, this is the automatic criteria which gives you the model, but it doesn't really work great most of the times. So I'm just using ARIMA, and in criteria, I am selecting. So this is the value of P, V, and Q. Okay. So I can actually give any value, but looking at that PACF function, I have a feeling that 100 should be a good model. But believe me, it is more like a random guess. It's a thumb rule. It's not necessary that this works every time correctly. Okay, so I'm just going to look at this model and see whether it is good or not. Okay, just to continue. Then you also have statistics. I want to know R square, root mean square error, mean absolute percent error. Then I also want to put display forecast because I do have future 7 days forecast to be done. I can save forecast as well. The statistics for individual models, I want to find out the autocorrelation and PACF, etc. And I want normalized BIC. Now, what is normalized BIC? BIC and AIC are two techniques which are used for optimization or picking up the best variables. Okay, which is very similar as your adjusted R-square. Okay, so what was adjusted R-square useful for? To identify which variable should be there and which variable should not be there. The only difference between this and adjusted R-square is adjusted R-square, higher is the better. This is lower is the better. Okay, BIC or AIC. BI is basically Bayesian information criteria. AIC is Akaki information criteria. Both are very extensively used for feature selection. Okay, so any combination of features which gives you minimum BIC or minimum AIC is supposed to be good. And generally, this BIC AIC tries to give some penalty to more number of features. Okay, so the more number of variables you put, to avoid overfitting, it will give you some penalty so that that particular feature, only if it is important, then it will be put. Otherwise, it will not be put. Similarly, I want plots, residual plots. They are important. Okay, and maybe I want this fit values, etc., which is fine. And if I want, I can also save the values. Presently, I'm not going to save it, but this looks good. Okay, so this gives you the model. Now, what you are looking here is, you can say, because we have used P is equal to 1, Q is equal D is equal to 0, Q is equal to 0. That's what the model we have used. So you can see the model statistics. R square is 0.73, not so great, but fine, you can say. Not exactly very good. Then what you look here is, this test should not be rejected. Remember that test showed that what is the significance, is the model is usable or not. So if it is significant, then it's not a good fit. If it is not significant, then it doesn't show lack of fit. The next thing what you see is, you can see because we have used lag 1, this should be significant. Okay, this is a constant not need to be significant, but the ARIMA model log, this one, whatever lags you're using, all the lags should be significant, and you can see it is 0. Okay, and one more thing you will see here is, these two are your boundaries, and this residue should be within the boundary. If any model has residues beyond boundary, you cannot use that model. So if these conditions are true, that means if this is fine, Okay, then this is significant and residues are within this. Then what you look at is the accuracy statistics. So you want lowest MAPE with lowest BIC. Okay, because MAPE is accuracy, BIC is you can say adjustment for number of variables. Okay, so lesser the BIC, better is the model. So if I have to compare two models, I'll check this two and compare it with the other models and see which one is better and which one is not. Okay. So to compare, I need one more model. So what I'm going to do is I'm just going to do analyze and repeat the command. But this time I'm just going to use, let's say, let me try 2. Okay, whether 2 is better or not. So P I'm taking 2. You can try actually anything. If it is becoming better than that, then you can actually use it. So this is 200 model. As I said, let's try with R square. So you can see the R square has slightly increased. It was 0.37 something. Now it has become 0.38. But that not necessarily means this is a good model. But this is fine. This is also not significant. So this is fine. But do you see that both the lags are significant?
No, ma'am.
No,
Okay.
ma'am.
Yeah, only first lag is significant, second is not. So I cannot really take this model, which is also understood by you seeing this normalized BIC. Okay, so because remember, your unnecessary variable you add, what will happen? Your BIC will increase. Okay, so lower BIC is always preferred BIC. So here BIC is 3.634, and what was the BIC before? 3.498. So which one is lower? This one. So this model is better than the previous next model. Okay, why? Because one of the variable is not significant. It's as simple as that. Okay, it's almost very much similar. Generalization is to do with the significance. If it is significant, then it is generalizable. If it is not significant, it is not generalizable. And you can see, but both have errors within the control. Okay, so that is not a problem. But I will not prefer this model. I would prefer this model. Is this clear? So these are the few things you need to check in the model. Okay. So first you start with maybe R square can be ignored, but first you start with in fact normalized BIC is given here also. So this should not be significant. Okay, this significance should be more than 0.05. Then all this coefficients other than constant should be significant. That is must. And error, the residue should be within the limit. This both lower and upper limit for all the data. Okay, if anyone one is out, then you need to do something. You need to change the model. You can't really use it. And this actually shows that how accurate you are really capturing the trend. Okay, looks quite okay. And this was with other one. Is this clear? Anyway, we are going to do this in detail. Actually, I might take a little bit maximum half an hour, 45 minutes to complete this particular topic. Then then what I can do is I can actually give you that mock test on Monday, and then on Wednesday we can actually have a question answer session or any doubts clearing session. Okay, sounds good.
Yes, ma'am.